Yeah. So as we all know, our today's topic is isolates in Dart and Flutter. It is basically today we are going to learn about how to implement multi-threading concept in Dart and Flutter. As we all know, multi-threading concept generally refers to handling more than one task, more than one type of code, running at the same time simultaneously. uh, okay, so there are two terms which we have to know before jumping on that. uh, Parallelism and concurrency. The parallelism refers to the concept when more than one task more than one task runs simultaneously at the same time. It can be run on different cores in the system, or maybe operating system can be handling it with different approach. Yeah, but they run at the same time. On the other hand, in when we talk about concurrency, here one more than one task takes turns to execute. There is system implemented, there is some approach implemented in different languages, in which there is a queue, and all tasks are present in the queue, and there are certain rules for the priority, depends upon the environment and language. So in that case we call it concurrency. We all heard of terms synchronous and asynchronous. We use that most of the time in Flutter. So we can take a quick look at that. In synchronous, the statements or code runs synchronously. The execution of code is in step-by-step manner. As you can see in the examples given in the screen, the left side is synchronous and on the right side is asynchronous. Each command is running in sequential manner. It is printed in sequential manner in the output. But on the right side, we have given some delays. Okay, so that it it is not running in sequential manner. This becomes asynchronous. Okay, so we are going to know a lot about isolate in this discussion. Here we can familiarize ourselves with these few terms which we are going to use a lot in this discussion. Isolate is nothing but a thread in the Dart environment. Dart environment run on single isolate. Okay, this is a single isolate environment. Dart is single isolate environment, and each isolate has its own memory, allocated memory. Okay, we are going to talk about how we can implement multiple isolates in the later part of the discussion. But as of now, we can remember these few things. Each isolate has its own event loop, its own micro task queue and event queue. Now we are going to discuss that in detail. Event loop. Each isolate has its own event loop. Okay. You can see that in this picture actually, there is event queue, micro task queue, event loop. Okay, and there is main isolate. Event loop is running all the time. It is like an endless loop which is running and executing the task. Event queue is the queue which have event which is mainly externally triggered events. All the input coming from the user gesture, drawing, timer, streams, all of them and futures, all these statements are handled by are all these statements are present in event queue. But all the actions, all the processes which are uh, generated itself by the internal actions, that is handled by microtask queue. There can be dispose method or anything which is system generated, that is handled by microtask queue because it has uh, higher priority than the uh, tasks initiated by the user. So in the event loop, first event loop finishes the microtask queue tasks. All the tasks of microtask queue will be finished first. And after finishing these tasks, event loop start taking tasks from event queue. We can understand this with this flow diagram and this picture. Here you can see main thread is executing, the event loop is running in the beginning, and it is checking whether micro task queue is empty or not. If it is not empty, then it will take out the first micro task in the queue and execute that. And if all the tasks are finished, then it will go to the event queue and execute all the tasks. This is the flow. So what we have covered is isolates are nothing but thread. In Dart environment, thread has their own allocated memory, which is not shared with any other thread. That's why we call this isolate, because it has its isolated memory space and it is not shared with any other thread. So that is why it is called isolate. One isolate has its one event loop, two queues, which is microtask queue and event queue. Okay, mainly Dart is a single threaded environment. If we don't create it explicitly, it is going to be all the operations and tasks are going to be run on single main isolate. So what's the problem here? Why we are learning this? What is the use of that? Suppose there is a situation where we want to perform some heavy computational task. For example, we want to run a background API call, which is which is very much heavy, which takes a lot of time, or we want to download some heavy file or large file, but at the same time we don't want to disturb the flow of UI in the app. So how can we handle this situation? So in this case, the solution would be to create another isolate and then perform that high computational task in that newly created isolate in the background, and the main isolate will be running parallelly, and the task will and everything will work smooth. There are two ways to create the isolate in Dart. Generally, there are two ways. Also, there is a package, external package for that. We can check that also. But we are going to discuss about these two things. First is isolate.spawn function, and second is by compute function. In this discussion, we are only going to discuss more about the isolate.spawn function, but we'll not give much time to compute. They are generally the similar, but isolate.spawn function give us more flexibility. So we are going to discuss that in detail. So you can see this piece of code. Here we are creating a new isolate. In the main function, we have called the method isolate.spawn. As you can see, there is a function named heavy task, which is doing some high calculation. and there is a isolate model class, which is a model. In isolate.spawn function, there we have to pass two parameters. The first is the function which we want to run after creating the new isolate, and second is the parameters required by that function. In this case, the isolate model. Isolate model is required by heavy task. Okay, there are only two parameters. First is, I'm again repeating, the first is heavy task, which is going to run when we call this statement isolate.spawn. Okay, and using this, the second parameter, when we call this isolated.spawn method, this function, immediately a new isolate is created and the heavy task function which we have passed in it starts running using the parameter we have passed in the second argument. Now, there is one thing to notice. We discussed that each isolate have their own memory space and they do not share with each other. So suppose we have created a new isolate, but it is not able to share the memory with the main isolate, the parent isolate. So, but there is a requirement. Suppose we are downloading a large file and we want to show the percentage of downloading in the UI. So in this case, a new isolate, a separate isolate is downloading the file, but UI is running in the main isolate, and we want to pass that information to the main isolate of how much download file is downloaded in terms of percentage. This is a real world example which we can relate to. So how do we implement that? So for that, we need to implement communication between two isolates. We can implement communication using receive port and send port. For each isolate, there should be one receive port and send port. You can take a look at the picture to understand it better. In the main isolate, there is a receive port, and in the another isolate, spawned isolate, there is also a receive port. Through receive port, we listen to the data sent by another isolate, and through its send port, another isolate send data to the main isolate. Think of it as like a pipe. Suppose main isolate has a pipe. One end of that pipe is receive port and the another end of that pipe is send port. So main isolate has that pipe. When main isolate is creating the new isolate, it send one of the end of pipe in that isolate, which is send port. Main isolate is sending its send port to the new isolate so that main isolate can listen through its receive port. So main isolate's receive port is there, but its send port is sent to the newly created isolate, and newly created isolate can send the data using that send port, and the receive port will listen to that data. We can understand this with an example here. This is the example which we are going to run. So let's understand this here. There is a main function in which we are going to run the main isolate. Suppose this create isolate function, this is the main isolate because this is going to run in the main function. And in this, when the main function run, this will start. In this main isolate, we have created a receive port, the receive port of main isolate. Okay. And here we are creating a new isolate, which is what we are doing here is we are creating a new isolate from the main isolate, and the isolate name is Shubham. Suppose the isolate name is Shubham, and I'm going to pass some data from main isolate to the Shubham isolate, and then Shubham isolate will read that data and then give a response back to the main isolate, and we are going to print both here. Okay, so then we can see it is working and we can understand how it is working. First, we have created the receive port. Now we are creating the isolate. In the isolate, we discussed that the first parameter is the function which we want to run. Here it is the heavy computational task. Heavy computational task function is this. We'll discuss what is happening in this function, but as of now, take a look at this. First, we have provided this heavy computational task function, and in the second parameter, which is required by the heavy computational task function, heavy computational task function needs a send port. So we are passing send port of the receive port. It is like passing one end of the pipe, which we discussed in our previous slide, that we are going to pass one end of the pipe to the newly created isolate, so that newly created isolate can send data using that pipe to the main isolate. So what we are going to do is the newly created isolate will use this send port, and this main receive port is going to listen to that data. So after running this, new isolate is created, and then this piece of code will be running. And in this newly created isolate, we are creating a new receive port, which is the receive port of the newly created isolate. If we want to send some data after creating the isolate, how can we do that? This is we are going to understand now. We have after creating new isolate, there is a receive port created of its own, and using the send port received by the parameter, we are going to send the send port of newly created isolate to the main isolate. This my send port, which is coming from here, this send port is used to send some data, and in this we are passing the send port of Shubham isolate. Okay, and this is captured here. In the main thread, we have created a listener to the my receive port. We have added listener to the my receive port, and we are this listener is listening. Whenever there is a message, it will check its type. Here we are sending the send port. So here it is checking if the message is of send port type, then save this in Shubham send port. So now the main thread received the send port of newly created isolate, which is Shubham isolate. First, let's look at that again. It can be a little bit confusing. Let's go through that again. first we have created another isolate and we passed the function and the send port of main thread. And in the new isolate, we created a new receive port and we send port of new isolate to the main isolate. And here we are receiving that. So main isolate can send the data back to new isolate using the send port received just now. So main isolate is sending data to Shubham isolate that Shubham, I'm taking an espresso coffee. It is sending data in form of string. The first child is this string and the second is espresso. In the new isolate, the Shubham isolate, it is also listening with some different method. The first message is this, Shubham, I'm taking an espresso coffee, and the second is coffee type. Now we are printing the message first, and then the second newly created isolate, the Shubham isolate, is sending the data received from the main isolate. It is sending, after receiving the message, Shubham, I'm taking an espresso coffee. Espresso, it is stored here in my message and coffee type. And now it is using the same coffee type in this string. And this is sent to the main thread. You are taking espresso coffee. Coffee type is espresso. You are taking espresso and I'm taking latte. So let's run this code and see how it is working. So when this string is passed to the main thread, it is received by the listener and it will check the type. The message is string and this will be printed. So let's run this again and then understand it. So this is the output. First it printed here, print message, and then the Shubham, this message, Shubham, I'm taking espresso coffee, received here, coffee type, and this is printed here. As we can see, it is printed. Now coffee type has the value espresso and it is sent here. You are taking espresso and I'm taking latte. And this is received by this listener here and it is printed. Shubham's response is this. Shubham's response, you are taking espresso and I'm taking latte. So now we have, this example is the complex one a little bit, because in this example, we are seeing communication to and fro in both the isolates. Main isolate is sending the data to the new isolate and new isolate is sending the data to the main isolate. And at the same time, they both are listening to each other. Generally, we don't have to do that. Generally, we can do is we can just send the send port of main isolate to the new isolate, and new isolate can directly send the data using that send port. We don't have to do this part. So that is the example. Now, in this, after running this, we are closing that, cancelling that listener, and we are killing the isolate. even if we don't kill the isolate, after running this piece of code, after running the function which we have passed, the isolate will be killed automatically. But there are still function given by this library explicitly if we want to perform some manual operations. Suppose we are using this in some API and we get some data, and in that we don't want to continue that process. And in that case, if we want to kill the isolate, then we can do that. If we want to pause the isolate for a time and then resume that, we can also do these things using these functions. This is the second method. We talked about the compute function. This is uh, similar in use case. Here also we are creating the new isolate using the compute function. We are passing the heavy task function, and second parameter is the data model for heavy task function. It is generally the same. Yeah. So now the conclusion is, we talked about the problem that Dart is a single threaded language generally. So but if we have some requirement, some use cases like downloading the file or running some API in the background so that it doesn't affect the processes running in the main thread in the UI, in that case it can be very helpful to do that. There can be a lot of other cases as well which you can think of, and in that it can be very helpful to implement isolates multi-threading in Dart. So yes, we can do that, and it is generally recommended that we should only perform heavy computational tasks in the new isolates, if yeah, because using the future await asynchronous, making the functions asynchronous, the small task can be handled in the main thread.